So in limits, the next type is use of expansions in evaluating limits. Use of expansions. तो किस तरीके की expansions की बात हो रही है यहाँ पे? There are few important expansions. The first one is e to the power x. So what is the expansion of e to the power x and how it is written? Just observe the pattern. I can write this as 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. The starting two terms can also, and I can write 0 factorial in the denominator क्योंकि 0 factorial भी 1 होता है, plus this x can be written as x पे power 1 and 1 factorial, and again x square by 2 factorial plus x cube by 3 factorial. So now this pattern is easy to remember. e to the power x है अगर कहीं पे, तो ये जो x है जो भी पावर पे है एक एक्सपोनेंशियल टर्म के ऊपर, the same thing you have to write again and again, and the power will be increasing by 1 and same thing का फैक्टोरियल डिनोमिनेटर में रिपीट करते जाना है. So this is the way you have to remember the expansion of e to the power x. Next one is log of 1 plus x. Now what is log 1 plus x? It is basically x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4 and then again plus, and this will continue so on. The important thing to notice is here no factorial is involved. No factorial. Otherwise the confusion will prevail in the problems while solving. So in the e to the power x expansion we can see there are factorials in the denominator, whereas in the log expansion there are no factorials. That is the first thing you have to notice. The second thing is, here you can observe whenever there is a power odd, suppose this is x, so I can write this as x to the power 1 only. So whenever the powers are odd there is a plus sign, and whenever the powers are even then there is a minus sign. So with this expansion you just remember that with odd you have to use plus sign and with even powers you have to use minus sign, and alternatively this will go on repeating. So that is all about the expansion of log 1 plus x. Sometimes you may need log of 1 minus x also, but you don't need to separately remember this. All you need to do is write this expression and replace x by minus x instead of again remembering one more expansion. This is a better idea. Now the third expansion is, again you can write e to the power minus x also, but again I would suggest that you can just replace x by minus x. So similar expansions no need to remember. We can go to a to the power x. Now this a to the power x is written as 1 plus x log with base e log of a plus x square by 2 factorial log of a with base e, this whole square and so on. So again this is also an exponential function only, because if you observe e to the power x it is similar to that only thing is instead of e here we have written a. So due to that there is a slight change in the way the expression has been written. Again I can write this 1 as x to the power 0 by 0 factorial, right? And I'm writing something here in the bracket, I will explain it later. Again I can write x to the power 1 by 1 factorial and then log a term, and then again I can write x square by 2 factorial, then log a term whole square and so on. Now I am introducing this log term here also, but power I am putting 0. So now you can easily identify the difference between log a, this e to the power x and a to the power x. That log a term is the extra term. Here you observe this expression, this expansion, because this correlation is the only way you have to go through so that you remember the expressions. Here you can observe this is the term which is extra, log a. Although power is 0 here, but in the next terms you can observe this is increasing, power is increasing from 0 to 1. So whatever power is here, same factorial you have to take in the denominator and same power on the log a term also. Here if it is x square, we have written 2 factorial and same power is here also on the log a term. So और कुछ नहीं है, simply e to the power x वाले एक्सप्रेशन में हर एक टर्म के साथ log a का टर्म आ गया है. And if you remember this a to the power x term, if you simply just replace in this expression itself, if we replace a by e, a की जगह पे अगर हम e रख देते हैं, then this LHS will be e to the power x, and all these terms, all these log terms will become log base e and again e, which is actually equal to 1, and that is why in the e to the power x expression you don't see any log term. I hope this is clear. So these three expressions we will be using much frequently while evaluating limit. Sin x. So this is the first of the trigonometry, but actually we are going to look at the fourth expression. Three already we have seen. So sin x is x minus x cube by 3 factorial plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial. Now notice one thing, that in the log expansion there was no factorial in the denominator. So whenever there is factorial in the denominator, it can't be the expression of or the expansion of log 1 plus x. So that is one thing. And there also we could see some plus terms and some minus terms, but there we observed the rule that with even it was coming minus and with odd power it was coming plus. But here the thing is minus and plus is alternate, there is nothing to do with the powers. So just put a note here, minus and plus are alternates, are alternately occurring. So some difference you have to identify, otherwise there will be problem while you write the formula or the expansion. So this is all about sin x expansion. You have to start with x and all the odd powers. So here two important thing, one is minus and plus will be alternate. You are starting with positive, like x doesn't have a negative sign, and then the next term is minus, then plus, then minus, and so on. But second important thing is only odd powers are there. Odd powers only can be seen. This is another important observation. So with these two observation you can remember that sin x expansion is x minus x cube by 3 factorial plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial plus again so on, it will repeat. If we have to write cos x term now, so already odd powers are gone, now it is the time of even power. So it will start with x to the power 0 by 0 factorial and then again minus even power is 2, so this will be 2 factorial, then again plus even power is 4, so this is 4 factorial minus x to the power 6 by 6 factorial and plus so on. So whatever rule we have followed in the sign expression, that minus and plus are alternately occurring, the same thing, same rule in cos x also. We have minus plus just like in the sine. And in the sin x expansion the powers were odd, here the powers are even. In the cos term the powers are even, and whatever powers were there, same thing, factorial in the denominator. So same rule here also we are following, 0 factorial, 2 factorial, 4 factorial, 6 factorial. Alright, so this is about the cos x expansion. Next, the final one is tan x. So again I am putting a star mark here because there is no factorial involved in tan x and there is no such pattern. So you just have to remember the first three terms of this expansion. Tan x is equal to x plus x cube by 3 plus 2 by 15 x to the power 5. right? So you have to remember this, that odd powers are 1, 3, 5. So up to 5 we are going, and this tan x expansion will be directly used in some cases. So there is no factorial term in tan x, and the one more term which was log x, or the log 1 plus x expansion, which you can observe over here. So this second and sixth one doesn't have factorial sign. We have to evaluate a limit x tends to 0, sin x minus x divided by x cube. In this particular case, you can observe if we directly substitute x is equal to 0, it will become 0 minus 0 by 0, which is actually the indeterminate form, which we usually want to avoid while evaluating limits, indeterminate form. So to avoid this, or to solve this limit when indeterminate form is occurring, we can use numerous methods, one of which is L Hospital's rules. So यहाँ पे sin x differentiation we can do, it will become cos x minus differentiation of x is 1, and in the denominator it will become x square. Again if we put directly, it will become 0 by 0. Why? Because cos 0 is 1, 1 minus 1 is 0, and in the denominator also it will become 0. That means one more time you have to differentiate. So it will become limit x tends to 0, cos x differentiation will be minus sin x, and 1 differentiation will be 0, and this will become 6x. Again if I put the x0, again it will be 0 by 0 form. That means again one more time I have to differentiate, and this will become minus cos x divided by 6 only. And when I substitute x is equal to 0 this time, it will be minus cos 0 or minus 1 divided by 6, and this will be our answer. So you can see, if the denominator was having cubic power itself, then we have to do 3 times differentiation, 1, 2 and 3. So what about the other powers? If power is 4, 5, then again the question will go lengthy. In that particular case, if you simply substitute the expression or the expansion of sin x in this expression, you will get limit x tends to 0. Instead of sin x, you will get x minus x cube by 3 factorial. Remember the odd powers in sin, and the signs will be alternatively minus and plus. So just substitute few terms, let's say 3 terms of the sin x expansion, and then we have minus x here, and then we have x cube here. Just by doing this one expansion, this x and minus x will get cancelled, and this x cube will cancel this x cube, and this x to the power 5 will be also cancelled by x cube, but x square will be remaining. Now when I substitute this x tending to 0, so this x square term will become 0, but here minus 1 by 3 factorial will be remaining. So minus 1 by 3 factorial is nothing but minus 1 by 6. Type 2, suppose we have an expansion, or basically the expression as 0 to the power 0 or infinity to the power 0. If we get such type of expressions, then it is better to take log. Let us suppose we have a limit of this form, limit of x tending to infinite, and then we have x to the power 1 by x. You can see, if I substitute this infinity in place of x, it will be infinity to the power 1 by infinity, and infinity to the power 1 by infinity will become infinity to the power 0, which means this type of scenario is occurring over here. So in this type of cases, you just assume that this is nothing but L. Let us say this value is L, which you want to find out, or whatever you say. Let us suppose y, if you are comfortable with y. So now just take log both sides. So it will become log y, and this will become log of limit x tending to infinite, x to the power 1 by x. Now this limit can be taken outside, and you can just introduce the log inside. So this will become log, because anyways this log is going to be associated with function only. Limit you can put at any time you want. So this log x to the power 1 by x again can be written as limit x tends to infinite 1 by x into log of x. But what is this? This is actually log y we are dealing with. Now again, to get back y, what is the rule? To remove this log, I can raise to the power of e. That is the rule, so that this portion will nullify. So I can raise the LHS as a power on e. So I have to raise the RHS also as a power on e. So this will be something like this, right? So now if this expression is nullified, so we will be left with y, and our objective was to find y only. If you see the first step, we have assumed that y is the given limit. So we are again getting back y, but this time we have a different way of evaluating. The limit in the original format is actually changed slightly. It is written in a different way now, which is much easier to calculate than it was previously, because now you can see this 1 by x log x can be simply written as log x by x, right? So this is a simple function raised on e as a power with limit of x tending to infinite. So if we see here the log function over the top, and we have a denominator x, so we can apply the differentiation technique over here. So log x differentiation will be 1 by x, and denominator separately if we differentiate it will be 1. So one time we have differentiated numerator and denominator, because here we are getting infinite by infinite, which is in the determinate form. And now if I put this limit x tending to infinite, it will be 1 by infinite, but everything was to the power of e. So this will become e to the power 0, which is basically 1.